Thanks very much, everybody, for joining us today. First of all, just acknowledgement of country as we gather in this meeting physically dispersed and virtually constructed. Let us take a moment to reflect on meaning of place. Do so recognize the various traditional lands in which we do our business today. Acknowledge the elders, past, present, and emerging of all the land, work and live on, and their ancestral spirits with gratitude and respect. I'm on the lands of the Wurundjeri people of the Kulin Nations, and I pay my respects to them as the traditional owners of the land where I'm meeting for you today. So I'll briefly talk about human aspects that impact software engineering in general, but also AI and cybersecurity, examples of these, and talk a little bit about some of the stuff we need to do to address what I think is a really important but under-researched and challenged practice issue. So in software engineering, humans are involved in all steps. We write code, we do design, we gather requirements from users, we work as teams, use tools, and obviously we use software. So software is produced not just for the sake of it, but to solve human problems. And one of the challenges is that humans are all different in many different ways. So there's lots of examples, bad examples, of biases in software that's crept in for various reasons. So lots of gender bias in user interfaces. Studies have shown different reactions to phishing emails. I'll come back to that one later, based on gender. Ethnic bias, again, you've probably heard about some of the terrible problems in poorly trained AI-based systems. So if you then start using them, for example, using security, they end up with massive misclassification problems. Lots of cultural bias, where software is developed without taking into account that people think and act quite differently based on cultural background, beliefs, things that are important to them. Language and age bias, also very severe, particularly with respect to cybersecurity based aspects of systems. Lots of people have physical and cognitive challenges, and again, a lot of software poorly takes this into account. And there's lots of ways that we need to design software to make it much better at addressing those issues that many people have. Ones I'm interested in: emotional bias, enjoyment bias. A lot of software is boring. A lot of software is stressful, and it's confusing to use. You often make mistakes. You don't want to make too many mistakes when you're dealing with security issues and privacy issues, obviously. Personality bias is an interesting one, where people think and act differently based on personality, and there's many others. These can all apply to both the teams developing our solutions as well as users. I'm interested in both of these aspects, particularly the user one, but also because people developing AI and cybersecurity and general software solutions are humans themselves. So in AI, we need, among other things, more trustable, fair, explainable software. It needs to be more robust, particularly when it's using diverse human data. It's not designed for one set of humans. Humans are very diverse, very different. And also needs to align to human values. There's lots of human values around privacy, but many others as well, about transparency, fairness, openness, etc. And a lot of software doesn't adhere to those, and it becomes very problematic. Interesting questions around how different people behave from a cybersecurity perspective. Do different people, depending on their human characteristics, behave differently? Do we need to take that into account when designing the interfaces to support them? Do we understand our users sufficiently well as software engineers? Do we bring in vulnerabilities that are introduced due to human-centric rather than technical issues of the domain the software is used in? So I'll just outline a few of the challenges I see in different aspects of engineering future AI and cybersecurity systems. So from a requirements point of view, who should we be talking to figure out what the software should do? How do we get their human characteristics taken into account, as well as the standard kind of functional, non-functional characteristics? How do we model and reason about these? So we're looking at trying to develop better ways to identify stakeholders, talk to them, get information from them, and use that. Here's an example of a project we did recently, looking at how do human aspects impact the doing of requirements engineering. So there's been a number of studies that show personality, emotions, motivation, and values have been studied, and they do impact how we do engineering software. Similarly, communication issues and distribution issues. It's rather inclusive, though, which ones actually impact the quality of the software produced, and how the human aspects of the requirements engineers and the stakeholders interplay. I think there's lots of interesting questions. How does this impact engineering future AI-based systems? How does this impact engineering future cybersecurity characteristics of systems? I think there's going to be some really interesting impacts of those human aspects we don't really understand yet, that have a large impact on how good the systems are we engineer from those perspectives. We did an interesting study a few years ago building a multilingual requirements tool. This is done by one of my Malaysian students. So she spoke both Bahasa Malaysia and English. And teams are diverse in many ways: language, location, gender, etc., and also culture. And this is an interesting, in the Malaysian context, teams are female dominated in software. This is for actually interesting cultural reasons. So it's an interesting place to study these things. But also we found there's some interesting cultural impacts on the engineering of requirements in this domain. We did an extension of this tool to capture security requirements. These are authentication, access control, privacy management, data provenance, and so on. Little example. So here's a simple use cases. They're called essential use cases in this model, and there's a English version and a Bahasa Malaysia version. The way you talk about interacting with systems and they respond to you in Bahasa Malaysia is actually different to English. So you can't use a Google Translate. You get the wrong interactions and so on. So the way you talk about it is different because of both language and culture. So here's an example of a tool we built where we've got both English and Bahasa Malaysia requirements and a mix of them down the bottom. And so some really interesting questions. Yeah, the culture and language and maybe other human aspects impact how we develop AI-based systems, how we develop cybersecurity systems, how do our human values, it may differ because of those cultural backgrounds, belief backgrounds, etc., impact the engineering systems we develop. Another example, we've been developing smart city applications. This is part of a smart parking application we developed, and trying to come up with quite a wide range of rich personas, we call them, to represent citizens that use smart city applications. We're interested in a whole range of human aspects: gender, age, do they have children, are they employed, what's their socioeconomic status, where do they live, how far do they have to travel, but also things like cognitive and physical challenges they might have. And some really interesting questions here. When you start thinking about the security aspects and the privacy aspects of these solutions, how comfortable are you, for example, adding information about payments, using the security features, sometimes it's quite complicated, remembering passwords and so on, and being assured of the data ownership, data privacy, etc. So requirements are problem space, design is solution space. Lots of questions here. Do developers understand the diverse humans they're building solutions for? How do we come up with design solutions that meet those human requirements? How do we know our models are complete, our designs are complete, we're using the right design strategies, do we have tools to help us, etc. So we're doing a lot of work in this space, looking at how we better support design and implementation around critiquing models, leveraging augmenting models, and giving developers better understandings of the human characteristics of users. One of the studies related to this we've been doing is looking at how people react to phishing emails they receive. So some email tools have some very limited support for detecting these, but humans often still interact with them, and often the interactions obviously are bad if they're trying to steal passwords, steal private information, steal banking information, etc. So in preliminary work we've done, we found that there is a difference in male and female behaviours. This has actually been borne out by other studies as well. Males tend to be a little bit too overconfident and over-trusting in a general sense. Extroverts and those open to experience more tend to modify their security mechanisms more, which tends to better support protecting their information, protecting their computers. Those are more conscientious, higher conscientiousness on that scale, tend to be more aware and more careful about potential threats. And the amount of training people have had, their proactive awareness, and also their level of neuroticism tend to help them pick up, if you like, potential cybersecurity threats from a phishing attack viewpoint. In terms of implementation, how do we build systems that take full cognizance of the diverse users we might have? How do we allow users to develop their own solutions, provide adaptive interfaces, etc.? An example of work we've been doing here is supporting a wide range of vision, hearing and motor control challenges people have, and allowing software to adapt to that. So in this example here, we've got a website that allows you to specify a whole bunch of preferences related to your kind of vision, hearing, dyslexic level, motor control issues and so on, and the website adapts. This is a Zomato replication, and this has been adapted in several places based on various settings a user has specified for themselves. We're very interested in extending this to, again, take into account different personalities I indicated on the previous slide that might influence one's susceptibility to cybersecurity attacks, age and culture and so on, which also have been shown in previous studies to have an influence, and adapting the ways that cybersecurity mechanisms are manifested to the users to take into account those human differences of users. And evaluation again. So how do we get feedback from users that things aren't working? How do we take into account that our testers might have very different approaches to evaluating the solutions they've come up with? How do we leverage large data sets that have been generated now, reviews of apps, reviews of websites, Stack Overflow discussions, GitHub issues, and so on, to find where human aspects have not been sufficiently taken into account in development and to try and improve those. One example is a tester personality. Did this a while ago. The inverted quotes, testers are from Mars, developers are from Venus, as our kind of theory there. So a test is quite different. We found neuroticism was not correlated, which we expected it to be, or not very much, but agreeableness and conscientiousness are. So the more agreeable you are and the more conscientious you are, the more likely you are to do software testing or testing related tasks. Interesting to see what impact this might have on implementing and testing, again, both AI and cybersecurity based system. Does developer personality make you a better developer of AI based solutions or cybersecurity solutions? Or if you have a certain personality type, do we need to give you some assistance in certain areas to make sure that you test them or implement them, cover different diverse human characteristics that you might not have taken into account sufficiently well. So some of the things we want to work on in this domain. We actually don't have a way of talking. I've been talking about these kind of human aspects, human values, human-centric issues, but they're not very well defined at all at the moment. And we need ways to talk about them, understand them, dialogue them, but both between developers and our stakeholders. We've got a lack of diversity in teams that develop systems, which is a major problem. So there's still a real challenge in attracting women to the discipline. It's a challenge in attracting a number of underrepresented groups to the discipline. And it's a challenge in retaining and promoting and moving them into leadership roles, all of which I think are absolutely critical to address these human aspects of diverse users. Our teams don't fully understand the diversity of their users and the different characteristics of their own from a human perspective. Means they might use the software in totally different ways and expect totally different things from it than they do. We lack tools and we lack design support for our developers to address these as well. A lot of the time our designs and our guidelines for implementing them are difficult to use, particularly to address accessibility issues, age bias, gender bias, culture bias, and so on. Teams don't understand how their own human aspects impact them engineering. As I mentioned with the personality of tester study, was an interesting one in this regard. And it's difficult for people to report challenges with using this software. And ultimately, we need to improve education of our developers of future AI, cybersecurity, and software solutions in general. So to summarize, our users are very diverse. Our developers are often quite different to many of their stakeholders. we as yet don't have really good ways of incorporating this diversity into the development processes we use. Believe it or not, software engineers are humans too, and they have many diverse aspects that impact their doing of software engineering, their building of AI and cyber-based systems. And we need better ways to engage with our stakeholders and better ways to reason about their diversity and build that in throughout the development process. Thanks very much.